Good evening, Dr. Storr. Today my colleague John and I are going to work out a problem on a chapter called Work and Energy. So we picked out the problem and, as I said, we're going to work it out. So now I will let my colleague John come here on the board and read the problem through, and let's see what we're going to do.
My name's Juan. We're going to be presenting this problem today. And our problem reads, we have a 400 kilogram box that slides down 4 meters, which distance is going to equal 4 meters, at an angle inclined of 30 degrees, and it is kept from accelerating by a man who is pushing back on it parallel to the incline. So we draw our picture. Our picture is going to look something like this. We have a box sliding down a distance of 4 meters, and then we have a man pushing against it, keeping it from moving. This is mass 1. We have our angle of 30 degrees. So we can see that our x-axis is going to be on this lane. Our y-axis is going to be going this way. And we're trying to determine A, the force of the man exerted by the man. B, we're trying to figure out the work being done by the man. And C, the work done by the force of gravity, which is going to be the work of gravity. And we're also trying to find D, the net work done on the piano. Alright, and now I'm gonna let Marco take it for A and figure out the force of the man.
Okay, as John was saying, I'm going to work the first question, which is asking to find the force done by the man here. To find the force done by the man, we'll need our the net force is acting on the box. So we have the force that is pushing this way by the man. We have the gravity, the weight, which is equal to the mass times the acceleration of the box. Okay, since the box is moving on an incline, so we will need to have a component which is the x component of the weight. So the x component of the weight, let's call it Wx, like this. Wx, which is equal to the mass mg sine theta. Mg sine theta, because since this is our theta here, it comes here, the sine, to find this little length here, we will need to use the sine of theta, which is here, mg sine of theta. Now, from there, since the direction of Wx, which is the x component of the weight, is going downward, and the direction of the force is going upward, we will have to switch one direction, which is going to be F plus X is mass times acceleration. Because our box stopped moving, we will have an acceleration which is 0. Now, we are left with this equation here. Now, the force is the x component of the weight, which is simply mg sine theta. mg G sine theta. From our given, we know that the mass is 400 kilograms. We know that the gravitation is G, which is equal to now 1 Newton. And our theta is 30 degrees. Good. When we try now to compute our force, we get 400 times 9.8 times the sine of 30 degrees, 960 Newton. So our force, so the force done by the man is basically 960 Newton.
Okay, now that we solve for force, we gotta figure out the work being done by the man. And we know that work equals the force times the distance. And knowing that the force we found out was 1960 newtons, and we know that the distance the piano traveled was 4 meters, so it's going to be multiplied by the 4 meters, which we will get a total work of 7840 joules. But knowing, since if we look at our x and y, if we draw it out, we had our x-axis, our y-axis. It's as if the piano's here, the man is pushing into the negative x. So knowing that, our work is also going to be negative, which ends up with a negative 7840 joules.
Well, how John find out the work done by the man, I'm going to find out the work done by the gravity. Actually, by convention, in our case here, the work done by gravity is going to be the negative of the work done by the man. What I mean is that work done by gravity is negative of the work done by the man, which is negative joule, which is 48 joule. Well, it's negative of the work done by the gravity is actually negative of the work done by the man, because the work of gravity is actually the potential energy, and by convention from what we learned in class, the potential energy is equal to the negative of the work. So that's basically why we are saying that the work done by gravity is the negative of the work done by the man.
Okay, so finally we have to figure out the network done on the piano, which is basically defined by the sum of the work that is being applied into it. And so far we can see that the work that came in play into this problem was the work of the man and the work of gravity, which we can also see that there was a force acting on the normal force, but since it's perpendicular and looking at it from the x and y, it doesn't come into play into the problem. So we basically will just have the work of gravity, which is the work of gravity plus the work of the man, which is basically the negative 7840 plus the positive 7840, which gives us 0 joules. and that is the network force acting up on the box.
Well, Dr. Storer, that was it for our presentation. Thank you very much for watching, and I hope you enjoy it.
And thanks also to whoever sees this video and takes the time to go through the whole thing. Thank you once again.